Weather changes and changes in precipitation. Weather forecasting is very important. It allows us to determine future climate expectations. It allows us to protect not also ourselves, but property, and it just positively impacts people in various ways. Some examples are forecasts that are based on temperature and precipitation. They're very important to agriculture on a yearly basis. And another example would be temperature-based forecasts are used by utility companies to estimate exactly how much draw they should expect from their plants over the coming days. So it's not a surprise that half the city turns on the heat one day. Our data is from a city in China called Wenzhou. Our data consisted of 30 data points, which was a 30-day forecast that consisted of temperature, air quality, precipitation, cloud coverage, wind direction, and it was through the months of September through October. Some of the numerical analysis methods that we used were piecewise linear and quadratic interpolation, and then the linear and exponential least squares approximation. So for the implementation of the least squares, I created a Visual Basic form application that accepted a user input for the x-axis and y-axis values, and it simply outputted the linear and exponential function. The design of the program was just several arrays and loops, and it outputted the final results on screen. And in order to print the results, the formula from the slide was just converted into code, which was ABNet, and there's a user interface allowing the user to simply compute both linear and exponential. And here's an example of the code on the right and the formula from the lecture on the left. You can see A0 right here and A0 right here. The summations were computed in this for loop, and then the answer was then outputted to a label on the UI. Here is a little GIF and a photo of the actual program. The user puts in their values here, and then their Y values here, and then they click approximate, and it gives them their function. So I went ahead and used precipitation, the maximum temperature and minimum temperature for my program. The reason is there were a few special cases where some of the data had zeros in it, which was yielded a undefined or a error in the code since you're multiplying and dividing by zeros. For example, precipitation, it didn't rain every day, so I went ahead and just did the linear approximation. But for Tmax and Tmin, I went ahead and used linear and the exponential approximation, and you can see those lines here. I simply just plotted the points and then put the equation in, and these are the trend lines that you get. Obviously, weather changes every second, and there's a lot of factors going into it, like air quality, natural disasters, events, etc., that have your weather fluctuate. As you can see, the steady trend is just a decrease, and that makes sense because you're transitioning from September to October and it's getting colder. The error rate that was calculated was about 9%, and this came from simply checking my work by hand and by MATLAB and through online sources, and the 9% is coming from the 3 decimal places as opposed to the 4, so it's not a huge deal. And lastly, the prediction between which one is better, in my opinion. I think exponential is much more accurate than linear, and here is why I think that. You can see here in blue, we've taken Tmax and put it up here, and these blue trend lines are the prediction of where the weather should be in the next 30 days. And then in the red is the actual next 30 days. So it's not too far off, but it looks like exponential is much more at home than linear is. And then here's the actual 60-day forecast altogether. And you can see that yellow is hanging real close by the red, and blue is not too far off. So in terms of accuracy, I think the exponential approximation is much better. I'm going to hand it over to Jai Wang, who's going to talk about interpolation.
Okay, so I did the interpolation part, and the variable I used in methods is the x-axis value, which indicates the maximum temperature, and the y-axis value, which indicates the precipitation. The language I use for these two methods, I use the C language and MATLAB, and I use several arrays for it, and I get the final results and the formula for the linear interpolation and the quadratic interpolation. So this is so on the left side, these are our class our lecture formula, and I use this formula is for the linear for the linear interpolation, and this formula for the Q is for the quadratic interpolation, and this code is from a C language code, and it's using for calculate the formula of the linear and the quadratic interpolation. I also divided these 30 days to the sunny and rainy and sunny, rainy, and cloudy days. So there are just like 4 raining days in the 30 days. Seven sunny days in the 3 days. So the rest of them are all rainy days. So these are my data. These are the charts I'm making in the MATLAB. So yeah. So from these three charts, I was trying to compare the temperature and the precipitation, and how the temperature influences the precipitation. So the trend, it seems like the precipitation is rising while the temperature gets higher. It's corresponding to the land climate from September to October. The precipitation decreases steadily, and it means from this chart we can see just during the 12 to 20 these 8 days, the precipitation is high, and as the time goes by, the precipitation is decreasing. So the complexity, just like the piecewise quadratic method, is much more complex than the piecewise linear method, but the result is more accurate. So from here, we can see the piecewise linear interpolation is just like a line, but it's not it doesn't very approach the results I indicated here. So as the climate analysis that belongs to the temperate continental climate, winter is relatively dry. There are less precipitation, and the summer's precipitation is slightly higher than the winter. So this is what I got for the information.
And in conclusion, we know that weather forecasting is just a huge factor in everyday lives. We're able to observe it, record it, plan, and predict our future climate. Every day we look at the weather and we plan ahead. So weather forecasting is very important for us a lot here. And just to recap, some of our numerical analysis methods. I mentioned that I think exponential is much more accurate, and I think that it is a more suitable method rather than linear. As you saw just a few minutes ago, the exponential is very similar to the actual 60-day forecast from the 30-day.
So I compared to the linear piecewise interpolation to the quadratic piecewise interpolation, I think the linear piecewise interpolation is much more simple than the quadratic piecewise interpolation. So basically, if you want to do a quickly measure of the whether you can choose the linear piecewise interpolation, but the result of the interpolation will not be very accurate. So compared to, but even though the quadratic piecewise the interpolation is much more complex, but the result is more accurate. And I think if you want to do a very concrete analysis for the wider here, so it's better for you to choose the quadratic piecewise interpolation.
Great, and that concludes our presentation. Thank you very much. Have a good day.